Recording in progress.
Hi everyone, welcome to FOCIL Breakout session number 8, which is going to be a bit special because, yeah, I think like the last couple of times we had a bit more time than what was planned to discuss implementation. So I think it would be nice to also have like one or maybe two presentations for FOCIL Breakout sessions as well, so we can learn about everything that's been sort of like top of mind around FOCIL for the past weeks, I guess. So yeah, if also anyone has like ideas about like guests or cool people to invite to present their work around FOCIL, or maybe even more generally censorship resistance, it would be good. Reach out to me or to yeah, maybe to me, and then we can set it up. So today we don't have just one, but we have two presentations. If we have like a lot of time left after the two presentations, I will also present something as well on FOCIL and statelessness. But if we don't, and that will probably be the case, then I will leave some time for discussing implementation progress and see where everyone is at. But yeah, I don't want to take more time than this, so maybe let's jump in. And first we have Julian, who is a researcher at the EF in the RIG team, which is also my team, and that is gonna present includer select, I think, which is very exciting because, yeah, for me, the meme is like bring your own transaction and like make sure it can get included, which is very nice and can be thought of as like a cool extension of FOCIL for the future. It's not totally fleshed out, if I understand. Like it's like it will need to be studied a bit more, but it's like super nice to have like new ideas come in on where FOCIL can go. So yeah, Julian, you're up.
Yeah, thanks for the introduction. Let me share my screen. There, I think you can see it now, right?
Yeah.
Nice. Okay, so hi everyone. I'd like to present Includer Select, which is an incentive mechanism for FOCIL. So FOCIL is currently unincentivized, as many of you would know. That means that includers are not rewarded for their participation. And designing an incentive mechanism is challenging for a number of reasons. First, it's difficult to get the incentives right. Designers can either focus on the long run to get a good set of includers, or they can focus on the short run to obtain a high cost of censorship. Secondly, incentive mechanisms are costly to implement. That means that they require core dev attention to implement and potentially requires to store the inclusion list on chain, which would be difficult for syncing as well. And finally, rewarding includers for their individual participation, so how well they made their own inclusion list, is tricky to reconcile with privacy-preserving variations of FOCIL, like ZK FOCIL that Benedict will present after me, because you need to reward people for their individual contribution. So you need to know basically what they contributed. It hasn't been for a lack of effort that we haven't been able to solve all of these problems jointly. There's been quite a lot of work on this. So for example, also, which you can see in a very, very tiny version here, is a collaboration led by Sarish from Duke University. And it's a very clever mechanism. Thomas has worked on this a bunch, and he introduced the includer fees here as well. And then we have a work in progress collaboration with Ikaterini from Nethermind, which is potentially promising as well, but here I'd like to present the alternative, which is Includer Select. So Includer Select takes a very different route than all of these previous incentive mechanisms. It doesn't aim to make a long-term set of effective includers. Instead, it allows people to become an includer themselves. It's very easy to implement, and it's compatible with privacy-preserving variations of FOCIL. And the key intuition is that it relies on exogenous incentives. So that means that those people that want their own transactions included, and if their transactions might be censored, they're incentivized themselves to create a good inclusion list because they simply want their transaction to be included. So there's no need for additional rewards next to that. So how it works is the following. There are 3 steps. Step 1 is the includer auction, which is where people bid for the right to become an includer. Step 2 is the auction settlement. So that basically means take all of the bids and find who are the winners of the auction. And step 3 is FOCIL. And so it's basically exactly the same as FOCIL works now. So includer select is only about appointing the includers, and it's not so much about how inclusion lists are made, how they are propagated, or how they're enforced. So the nice thing about includer select is that a large part of it can work on the execution layer, even via a smart contract. That is because the people that are bidding to become an includer in includer select don't have to be staked validators. Basically, what they need to do is they need to have some ETH, for example, on the execution layer, and send their bid as a normal transaction, and the auction settlement can be done via a smart contract. And that's also a hint on why it's quite easy to implement, because it doesn't need that much core dev attention in that sense. And then the last part, FOCIL, relies mainly on the consensus layer, but of course there are also execution layer parts about that. But for the purposes of this presentation, I'd like to contain that to the consensus layer. So the first step in these is the includer auction, which works mostly on the execution layer. So consider 3 people, Alice, Bob, and Charlie. They have their bids, which are the form bid, which is an amount. So let's say 1 ETH, bytes, how many bytes they want to get for their includer seat. Because remember that in FOCIL, space is measured in bytes and not in gas units. So people bid for the right to create an inclusion list worth, let's say, this many bytes. And then finally, the includer ID, which is basically the validator key. So which validator or person will be sending the inclusion list of the network, and who should people listen to, basically. So what people do is they broadcast their bid, and it should be included in the block. The funny thing here is that we actually leverage FOCIL again. So people are bidding for the right to be an includer in block N. So what they do is they submit their transactions in block N-1. It should be included, and either it's included via FOCIL. And then we move to step 2, which is the auction settlement. The first part happens on the execution layer. So there is a smart contract that runs a knapsack allocation, which basically says order bids by how much they pay per byte until there are no bytes left. And FOCIL has a total amount of bytes allocated to it, so you can basically order them, like that. So let's assume that Alice bids the most per byte, Bob the second most, and Charlie the last. What could happen then is that some of these bytes are allocated via the execution layer. So for example, Alice and Bob are allocated their bytes, and Charlie isn't. And then potentially there is also some randomly selected includers via the consensus layer. And these two can be mixed and mingled a little. So for example, what you could do is you could say, okay, well, half of the includers can be selected randomly via the consensus layer, like normal validators, to ensure FOCIL works kind of like we have worked on up until now. And then you can say the other half could be allocated via the execution layer in the smart contract. You could also say that everything is allocated via the execution layer in the smart contract. And if not everything was allocated, so in total there were fewer bytes demanded than allocated, then we randomly select the leftover bytes via the consensus layer. But in total, there should be a fixed number of bytes allocated, and therefore includers are selected in this second step, basically. What we do then is we move on to the third step, which is FOCIL itself. So remember, Alice and Bob were allocated their bytes because of how much they bid, and they selected one includer ID. And what happens then in block N is that this includer ID becomes part of the inclusion list committee, and it sends its inclusion list, and that inclusion list probably contains their transaction. The interesting thing here is that the person with the includer ID doesn't actually have to be the same person sending the transaction. So it's kind of like stealth addresses vibes in that sense. And then potentially there are still some randomly selected includers, depending on how you structure the mechanism. Again, you can say that there must be some validators randomly selected for FOCIL. You could also say that if there is any bytes left over, then there are some randomly selected. So yeah, this step then basically pipes into the FOCIL mechanism as we know it, and nothing changes from here on out. So how it works, or how its properties work, is the following. So first we'll tackle how it solves the incentives issue. And we look here at the cost of censorship. So again, includer select tries to make a high cost of censorship, which is the minimum cost an adversary would have to pay in order to censor a transaction. And it's based on a paper from Elijah Fox, Malash Pai, and Matt Lesnick that formalizes this cost of censorship. And here we normalize it. And normalize means divide by the fee that the censored user is willing to pay. But you don't have to care so much about the specifics here. Basically, the intuition is that if someone wants to censor someone from becoming an includer select, what they have to do is they have to buy all of the bytes. Whereas the person that wants to send their transaction, the person that's being censored, only needs to pay for the censored amounts of bytes, basically. And because one transaction is likely not to be all of the bytes of FOCIL, this fraction is likely to be larger than 1, meaning that the costs of censorship are higher than the cost of inclusion. And now you might think that it's not so nice that people have to bid in this auction because you want it to be free, basically, for users to get censorship resistance. And I'm going to tell you something that might sound very counterintuitive, but in principle, the cost of inclusion here is 0 as well. So even though we have a higher cost of censorship than 0, the cost of inclusion should, in principle, be 0. But yeah, I'll try to convince you in the following here. And I would have to say like this holds usually, and it holds usually because of the following intuition. Ethereum determines the transaction supply. So currently that's about 36 million units of gas. In FOCIL, that translates to some amount of bytes. But by 1559, it means that we have a max gas limit and a target gas limit. And 1559 sets the base fee such that the transaction demand is on average about the target gas limits, which is half of the max gas limit. So on average, or usually, as I say here, which adopts the terminology of Tim Rothgarden, the transaction demand should be lower than the transaction supply. And now, not everyone has to be an includer because most transactions won't be censored. So by like normal inclusion, by that time being transactions that are just included because they send them to the public mempool or whatever, the demand to be an includer is even lower than the transaction demand. So we have that transaction supply is larger than transaction demand, which is larger than includer demand. And so in total, includer demand is quite a lot smaller than transaction supply. And since supply is very much larger than demand, the price of it should basically be 0. Also because the marginal cost of providing the includer seat is 0. If that makes sense. And so the auction here is not so much meant to incur any costs. The auction works as a deterrent, and there are actually no costs of being censored. And I see that the slide rendered a bit weirdly. But yeah, that's, I think, an important thing here. The auction is I would say, like a technicality. It doesn't actually matter that much. We just have to have it there for if there is someone who's actively trying to censor your transaction. Because if that's the case, then you can outbid them. And if someone is actively trying to censor your specific transaction, which will be a very hard thing to do because in the includer select mechanism, you can bid basically anonymously, and people don't even know which transaction they are censoring. But let's say that they do magically know it somehow. In that case, your cost of inclusion will be positive. It won't be 0. And then we need the auction in order to say that the cost of censorship should be higher. But because people know that the cost of censorship will be a lot higher for them, and because they can't actually target your specific transaction, that's very unlikely to happen. And if that doesn't happen, then your cost of inclusion is 0, and the auction works as a deterrent. Then onto the ease of implementation. So a lot of this works in a smart contract. So that's relatively easy to implement compared to other consensus layer changes. And what's really nice about this is it preserves the property of FOSS so that ILs don't have to be stored on chain, which means that they're not relevant for syncing or they don't bloat the state and stuff like that. And that immediately brings us as well to how it's privacy preserving. We don't actually store the ILs on chain. We don't reward people for their individual contributions. Again, remember the key intuition is that we rely on exogenous incentives. People want their own transaction included. And so since we don't reward people ex post based on their individual contributions, we immediately preserve privacy because we could combine it with something like ZK Fossil. And then finally, I'd like to pitch like the big picture of this. I see it as every house should have one light client that fetches the state from some decentralized state provider, which means that in principle, you could construct your own transaction without trusting anyone. And so this happens, the light client crafts the transactions. it then grabs a includer select seat. And again, the supply should be vastly larger than the demand. So you should have no problem getting your includer select seat. And then that means that since you're an includer, you can trustlessly insert your own transaction. Again, FOCIL relies on like this 1 out of n property. And if you are that one, you basically have to trust no one else than yourself. And so you get trustless transaction inclusion, which I think is really, really cool. Yeah, so I hope I convinced you guys somewhat of includer select at least being an interesting mechanism. If you have any further questions, I'd love to hear them. You can also reach me on Telegram. And if you want, you can scan this QR code for the includer select post or look on my mirror. Yeah, so that's it. Thanks for your attention.
Awesome. Yeah, thanks a lot. Are there any questions? I have some, but I will give priority to any other one. Yes, Terence.
Yeah, great presentation. So I think like someone could also censor the first part, right? Which that the first option is that for someone to become a includer or to essentially to basically bid, and someone could censor your bid, so such that you can't even become an includer, right? So it's kind of like a recursive problem here that like someone could use the includer to become an includer for the future slot, something like that? Is there like a recursive problem?
Yeah, so I'd say it's recursive. I wouldn't say it's a problem though. I would say the recursiveness is actually really, really cool. So indeed, like becoming an includer is somewhat of a sensitive process. As I said, the supply should be vastly greater than demand. So I expect if we say includers are selected based on what they bid, and if people don't bid, then they're randomly selected. What happens then is people will be randomly selected, and so FOCIL will work. And since these bids are basically on the execution layer, they're just transactions, they're included by FOCIL itself, which is kind of the recursive thing. But it's definitely a bit of a sensitive issue. So perhaps it's something we can look more into. But I up until now, I feel like it works kind of cool in a cool way, the recursiveness.
I had a small question, like, okay, imagine a world in which you actually you want to get your transaction in, and the cost is not zero, because imagine there is quite a lot of censorship and it's tricky to evaluate like as in individually, like as a user, like I don't even really know, like you're like, I want to include my transaction, but how much should I pay is a bit like weird. So yeah, I was just wondering, maybe it's a bit stretched, but like in that world, like will people be incentivized to just like outsource this to third parties that can price their bids like in a more sophisticated way, and then we lose some of the censorship resistance properties?
Yeah, so first of all, I would always imagine that there are like some randomly selected consensus layer participants that become includers. So you kind of inherit like the normal FOCIL censorship resistance here. So I wouldn't expect us to be in that case. But let's say that's for some reason like everyone in the world wants to target your specific transaction, then it definitely becomes trickier. I think it's very hard to design for such a world. Yeah, I still feel like this is somewhat nicer because like the theoretical cost of censorship, which is somewhat of a nice concept to see how difficult it would be to get your transaction included, stacks in this way. So first of all, people have to censor you from becoming a winner in the includer select auction. Then they have to censor you from getting your transaction included by some other FOCIL participants. And then they have to censor you from being included by the block producer. So in that way, it kind of stacks. And so I would imagine the cost of censorship to be higher in this regime than under regular FOCIL. But yeah, again, it's quite a fresh mechanism, so I'm happy to have more chats about it.
Great, thanks. Thanks a lot. Yeah, if anyone has questions, feel free to reach out to Julian, but I think in the interest of time, we can move on to our next presentation, which is made by Benedict, and it's the first presentation on ZK FOCIL. So yeah, happy to hear it as well.
Okay, so can you see my screen?
Yes, maybe.
Maybe I should,
Yeah,
like this.
perfect.
Okay, perfect. Good. So yeah, this presentation is going to be about CK-Fossil. So I'm Benedict. I'm from the Ethereum Foundation cryptography research team, where I do all kinds of cryptography research. And one thing that I've looked into with George and Thomas is CK-Fossil. So we wrote an ETH research post about this, and I will just use the time here to present it and to give you a rough overview of what it does and why we want it and roughly how it works. And to do that, I first want to set the stage. I want to sort of get everyone on the same page about how I look at Fossil and what are the elements of Fossil that are important to understand CK-Fossil. So let's start with that. So, and I want to say this is going to be a very simplified picture of Fossil. So we have a set of parties, and for now, for this presentation, let's just say these are the validators. Now, the first step is that we select randomly this inclusion list committee. And so you can think of this as these validators having public keys, and based on their public key, we do some sort of random election, and then everyone knows whether they are in the committee or not. And once this is done, they will sort of assemble these inclusion lists and publish signed inclusion lists. And then we have this magical box, our consensus rules that sort of enforce that if an inclusion list is signed by a committee member, then we can sort of force inclusion. And the idea is that if one of these committee members is honest, then this provides censorship resistance, and we make sure by this random election and choosing the committee size correctly that with high probability we have one honest committee member. Okay, so this is the big sort of the very simplified picture of Fossil. We have these three elements. We have a random election, then we have inclusion lists that are signed by these committee members, and then somehow this leads to forcing inclusion if an inclusion list is signed by a committee member. Okay, so let's look at this again. We have our validators and we have our inclusion lists. And from what we have seen now, it is pretty clear that the link between inclusion lists and validators is public. So everyone can see this inclusion list has been sent and signed by this particular validator. Okay, so we sort of have a public linkability between validators and inclusion lists. And the question where we sort of started with CK-Fossil is whether we can hide these links. So we want to break the link between inclusion lists and validators. And now you may ask, why do we want to do that? Well, one reason is that if the validators who assemble and sign these inclusion lists, if they are publicly known, then they become a target, right? You could try to DDoS them or something like that to censor. And another reason is that if you as a validator know that you will be linked to the inclusion list that you publish, then you will be sort of you will fear that you face consequences for including certain transactions, and that will probably lead to you censoring transactions. Okay, so it's a good idea to hide this link. And now that brings me to the goals of CK-Fossil. The overall goal is, as I said, to hide these links between inclusion lists and validators. But let's make that a bit more explicit. So in terms of security, we have this goal that we make the inclusion lists unlinkable to the validators, but we want even more. We want to even hide the committee that is selected in order to increase the anonymity set. And that means we still need some form of committee election, but this needs to happen in a hidden way under the hood. And even though that happens in a hidden way under the hood, we want that it's still a fair committee election and it's unbiased, in order to guarantee that there's still at least one honest party in this randomly elected committee. And an adversary can sort of not prevent an honest party from getting elected, and it can also not significantly boost its probability of getting elected. And in addition to these security goals, of course, we have some real world constraints, right? We don't want this to be just a theoretical thing. This needs to be applicable for the Ethereum context. So of course it should be efficient. It should be not a very complex thing. So we want to avoid using very complex cryptographic machinery, for example. And ideally, we do that with minimal protocol changes. Okay, so that was the goal, and that was where we sort of started with this ETH research post. And we also have some way of achieving this, of course. So we get CK Fossil by using a cryptographic primitive that is very well known, and a classical primitive that is called a linkable ring signature. So this is a variant of digital signatures, and I will explain what it is exactly in a minute. But as it is a classical primitive, there are classical constructions of it. Unfortunately, it turns out that if you look at them, they are not really well suited for our application because they are just not efficient enough when we have a very, very large set of participants or validators. And so what we did in the post is we said, okay, let's just throw a very large hammer at it, namely CK snarks, and we provided an instantiation of linkable ring signatures from CK snarks that should be efficient enough to be used in CK Fossil. And even though this is currently our best candidate, I still think personally that this is more of a prototype that sort of shows what kind of properties we want. And there needs to be more research to get a less complex solution, because if you want to specify a CK snark in the Ethereum spec, that's going to be quite complex. And yeah, so for the rest of this presentation, I just want to focus on this part. I want to explain what a linkable ring signature scheme is and how we can use it to achieve our goals in CK Fossil. And for that, we start with ring signatures. So think of the following setting. We have a bunch of parties, say n parties. They all have a public key and a secret key. And now we take their public keys and we put them together in what we call a key ring, which is just a fancy word for the list of their public keys. And now let's say we have one signer, signer I, holding its secret key. Then we want that this signer can sign on behalf of the keyring, and anyone can verify that, but no one will see which signer it actually was. So let's make this more precise. Say there's a message that needs to be signed, then this signer can run a signing algorithm, generate a signature, and this signature can be publicly verified. And in contrast to standard signatures, it will not be verified with respect to the individual public key of the signer, but with respect to the list of all public keys. And the intuition, again, is that you can be sure that one of the signers signed, but you don't know which one. Okay, so the security properties here are you can only sign if you have one of the secret keys, but the signature does not reveal which secret key you had or which signer you are. Okay, so this adds a sort of anonymity feature to digital signatures. And now let's see how we can use this to improve the anonymity or unlinkability properties of Fossil. So this is again the picture from before. We have this three-step process. We have the random election, and we have our committee that signs inclusion lists, and then we enforce inclusion. Now, I want to use ring signatures. We are not at linkable ring signatures yet. I want to use ring signatures. So I will take the committee, and let's say after the election happens, we sort of make public who is in the committee, and then we put their public keys together in this key ring. And now instead of using a standard signature to sign inclusion lists, they would just use a ring signature. And now if this rule in the consensus part, which says if it's signed by a committee member, this just becomes if it is signed with respect to the key ring. This is exactly what the ring signature tells you. If it is signed with respect to the key ring, then it must be that one of the committee members signed it. And then we force inclusion. And because the ring signature scheme is anonymous, you don't know which committee member actually signed it. And so we broke the link between the committee members and the inclusion lists. Unfortunately, the committee is now public and it's not hidden, right? The anonymity set that we have in this example would be of size 3, whereas our goal was to hide the committee and make the anonymity set as large as possible. So it should be this whole set of validators. And this is where linkable ring signatures can help us. So this is again the picture of ring signatures, and now linkable ring signatures add another element to that. And that is called the key image. So you have not only a public key and a secret key, you also have a key image. And you can think of this key image as being a unique pseudonym of your public key. So how does that work? Well, you generate the key image when you generate your public key and your secret key. And then when you sign, you not only publish the signature, you also publish the key image. And you can only verify this in combination. Now, the properties that we want are as before. You can only sign if you have one of the secret keys. And the signature, now in combination with the key image, does not reveal who you are. It does not reveal the index I. But we want a third property, and that is that the key image is unique given the public key. Okay, so this key image is this magical cryptographic object that is uniquely determined by the public key, but it's still not linkable to the public key, right? Because the signature key image pair does not reveal the index. Okay, and why is this called a linkable ring signature? This is just a side note. Because this key image is uniquely determined by the public key, if you sign twice, you will have the same key image there, and then people can see that someone signed twice. They can still not see who you are, but they see that you signed twice. Okay, this is why it's called linkable ring signature. But for us, this property will not be that important. The property that is important is that the key image is unique given the public key. Now, let's see how we use this in FOCIL, and this will be actually how CK FOCIL works. So we start with all parties that we have, all participants, the validators. And now what we do is we just put all of their public keys in a gigantic key ring. And now, because we use linkable ring signatures, these validators also all have key images, which, as I said, are unique pseudonyms of their public key, and they keep them to themselves. They don't reveal, I have this key image. Now we do a random election, but we do this random election based on the key images and not on the public keys. So remember, before I said you can think of it as take the public key and determine whether you are elected or not. Here we take the key images. And because the key image is uniquely determined by the public key, this should be as good as using the public key. You cannot try different key images, for example, to improve your probability of getting elected, because the key image is just unique given the public key. So now with that, we get a committee, and this committee is now hidden. So everyone just knows whether they are in the committee or not. They don't know anything about the others. And now to publish an inclusion list, you just use the linkable ring signature. So you publish the ring signature and the key image. And our consensus rule says if the inclusion list is signed with respect to the key ring, so that means we know one of the validators has signed it, and the key image is in the committee, so then we know it's one of the committee members, then we force inclusion. Okay, so why is this anonymous? Well, because the ring signature and the key image together do not leak the index of who signed actually. So it could be anyone in this gigantic set of validators. And it is a fair committee election because the key images are unique. Okay, so that's the overview of how CK FOCIL works. Let me finish this talk by explaining what the next steps are if we really want to make this work. And I think they are threefold. So the first step is, I said we have this generic construction based on CK snarks. We should try to understand the efficiency of that. That is works. Then, as I said before, I'm not entirely happy with this construction, just because CK snarks are a very complex object, and there are also some security concerns. And so there is a very nice cryptography research question, which is, can we build these linkable ring signatures in a very efficient way while avoiding generic CK snarks? As I said, there are classical constructions, but they are not made for this large set of participants. And then the third question, and I think this is very important, is a legal question. So what are the legal consequences of all of this? If we decide to include this in Ethereum, we have to do that right. And we need to make sure that there are no legal problems that we face, because this will be some sort of enshrined anonymity on layer one. And of course, there are legal consequences. We should clearly understand them before we decide to implement this. And yeah, that's all I wanted to say. Thanks.
Thanks a lot. Yeah, this was great. It's even for me like having like a rehash of ZK FOCIL and the construction is super nice. I have a question like okay, I'll let Katja go before then.
Hello, thank you. Very interesting. I have a question. If a validator joins already running blockchain, what happens with the key with this ring signature? Does it change it, and how to check the key image then?
Yes, very good question. So I will go back to my slides. This is something that I completely ignored in the presentation, but this is a very important aspect to consider. So let me go to the definition of linkable ring signatures. Yeah. So as we see here, the ring signature works with respect to a fixed key ring. The thing is that the key image is unique given the public key, and it does not depend on the key ring. So that means if a new party joins, we will have to update the key ring, but we will not have to update the key images. And this is good and bad. It is good because, well, you don't need to recompute key images, and it does not depend on the time, whether you are sort of in the comedy or not. But it's also bad because there are implications for the size, the effective size of the anonymity set. And this is actually something we also need to study. And I mean, there's a very simple example. Let's say you have 5 people and one of them signs, and then 4 of them go offline and 4 new people join, and then this one guy signs again, then you clearly know who it is, right? Just because it was the same key image, but it was sort of the intersection of these 2 key rings was just size 1. Okay, so there is sort of something that we lose by publishing these key images in terms of the anonymity set. But if there's a way to update all key images at the same time, and then you can sort of, as a countermeasure to that kind of problem. However, whenever the key ring changes, we will have to recompute some additional information that I just hide here in the signature, which, yeah, we will figure out during the benchmarks how expensive that will be and how often you need to do that. And yeah, so this is still a very open kind of question. So what do you do when parties join? How often do you change sort of the key images? But in principle, this primitive says that the key image does not depend on the key ring. Just the signature, of course, depends on the key ring. And that's it. Yeah, so I hope this somewhat answers your question.
Yes, thank you.
Great. Maybe let's take Mark's question, but there is also a question in the chat. So maybe async will be good.
Hi, thanks for the presentation. So I just had a question about the key images. So you said that the validators would keep this secret, right? But how would you run a random election over it without knowing the key images?
Yeah, very good question. So let's say, so there's one way to do it, and that is you take the hash of the key image and some random beacon, for example, taken from Randao, and you check if you compute this hash, you check if the leading three zeros, if the leading 3 bits are 0 or something. Yeah, you can have that kind of election. And now, if I have my key image, I know whether I'm in the comedy or not, but no one else knows it. And then once I publish this inclusion list, then I also publish my key image, right? So everyone can now check whether I'm in the comedy. Okay, so it's kind of a hidden election, but once you decide to reveal yourself, you can convince people that you are in the comedy. But the thing is, at that point, it will not reveal actually who you are. It will just reveal there is someone who has this key image who is in the comedy. Yeah, so I hope that answers the question.
Right, but would that mean you can have a deterministic committee size, right? Because at the moment we have 16, but if it's just based on the number of zeros, it could be any number.
It's
right?
not deterministic then.
Okay.
Yes.
All right, thank you.
Awesome, great. Yeah, I had a more like global question. Let's see. Okay, maybe I'll just ask it, but like it was more about like if it seems like there are two paths, like the classical construction, but it's not. I mean, we haven't found a way to make it efficient yet, and then the generic snark path, which is like not great because it's hard to like specify it and it's very complex, and taking it into like Ethereum specs is a bit like of a moonshot. Is there like an alternative path? Imagine like even like combining it with like includer select or something where like you can do generic snarks out of protocol where like participants are not necessarily like validators, but just like people that want to become includers. And then, like the generic ZK snarks now don't have to be like implemented in like the Ethereum specs because people will come with their own proofs in some ways. So that can be outsourced to like, prover networks or provers or anything. So it's a bit high level and I'm not sure. I'm sure there are like tons of details to figure out, but that was a question that popped up.
So I think that would be great if we had that, but I assume it's very hard to do something like this. And one of the reasons is that we don't need just snarks, we need CK snarks, right? If you are in a setting where you have snarks, then often you could just say, you just write the uncompressed verification in the spec, right? And you say, okay, there's the verifying with respect to the snark is sort of, by soundness, it's the same, right? But for the CK snark, we could not just write the unsnarked verification in the spec because then you leak essentially who you are. So I think this is much more challenging than if it were just a snark and not a CK snark. So currently I don't see a solution to that, but of course that would be great, yeah, to move the snark out of protocol and that would be much better, yes.
Okay. Yeah, awesome. Thanks a lot, Benedict, and thanks a lot, Julian, for your presentations. It's great. Sophia, I think there is a question in the chat, but maybe let's move to implementation things. Just one quick thing before, I want to get a vibe check on like how people feel about having more presentations like this in the breakout sessions. 1, 2, do you guys like it? Do you think it should be more about like implementation only? Okay, I see a lot of thumbs up, so that's great. We'll keep doing that. I think it's also like nice to have new ideas come in and like keep up with like the state of the research at the same time. So that's awesome. Thanks a lot again. And now let's maybe move to implementation discussions. I think the first thing to celebrate is the interrupt between Prism and Lodestar. So this is great, like that we actually reached that point. I'm super happy, and thanks everyone that actually worked on this these past few weeks. No, I saw some discussions. Yeah, thanks a lot, Jihoon. I saw some discussions on whether we should use an activation epoch or like a sort of like a real fork. So I haven't like followed super closely, but maybe some. I know like people wanted to discuss it, but in a bit more detail this in the breakout. So maybe that's a good time to do it.
Yeah, I guess on Lighthouse's end, if we were to do an activation epoch, it would be much simpler from like a implementation standpoint. Every time we need to add like a real fork, a few thousand lines of boilerplate. Um, and yeah, from like previous work, like on PeerDAS, activation epoch worked pretty well for like implementing and simplicity wise. I know someone said Nimbus might have trouble with like kind of like this activation epoch stuff. So, uh, but yeah, that's just I guess my opinion of it.
I
Great.
guess I don't understand one thing that is someone can help me understand it is that like what do we get with the real fork that activation epoch doesn't give you here? I'm actually curious because there's no change in the block or the state format, right? So I think activation epoch is all you need. So yeah, I guess I'm trying to hear the argument of having a fork. So what do you get in a fork that activation epoch doesn't get you?
So I guess I could quickly iterate on what I already noted on Discord. So from a code-based perspective in Lodestar, we use the fork in a lot of places. Like when we subscribe to a new gossip topic, we use the fork sequence, not like an epoch, or how we call the engine API constants and stuff like this. Also, I looked at our spec test iterator and it's all based on the fork. So I'm not like, let's assume we have SSC static tests. I guess this is a simple example. How would you, like, does your spec test iterator work with if you just use a fork or if you use an epoch?
Yeah, I believe so. Okay, so I think I understand you better now. So when you say fork, you mean a different fork version. Is that right? Or is that something
Yeah,
else?
like, or just, yeah, like use the fork as a namespace. Like, if you look at how the spec is structured, they also use the fork there, right?
Yeah. That's fine. I think we can do that in Prism pretty easy, right? I think we can just essentially reuse the same block and the same state type, but use the fossil fork number instead of the Fulu or the Elytra fork number. So I think that's the right thing to do. But yeah, I guess my comment was like I was against copy and pasting something, just name it EIP 7805, but without any change. But I think here the change is just the fork version, which we could just yeah, let me think about how to do this. I think there's a way to do it in Prism that's pretty easily. So okay, I guess I understand the problem now. The problem is that you want a different fork version that's 7805 specific. I got it.
Yeah, I think either way, in Lodestar, we can make it work. As I noted, I think if we just use the same fork version as Electra, then our fork digest will be the same, even if you just use an epoch, right? So I think,
But I do think the right thing to do is to use the fork version. I think because you want to upgrade from Electra to Fulu to 7805, right? And this wouldn't work if you use the same fork version. That's kind of weird.
but that's the argument for using the epoch, no? Or
Yeah. So now I understand it better now. Yeah. So I think fourth version is the right thing to do, but yeah, I need to look at Prism, or I think Jinhu may have started looking at it already, like how to do this nicely.
yeah, I
Because
think
we,
so.
yeah, go ahead.
Yeah, I just brought this up with Nimbus because I heard they even have issues with the BPO, and this only touches like some list limits, right, on regresp and stuff. And for Fossil, you have completely new containers, and I would guess they have a lot of issues. I'm not sure if someone from Nimbus is here.
But even in PeerDAS, there's no change in the block nor the state today as it is. And yeah, and then we also don't copy. So if it works in PeerDAS, it should work for FOSSIL. I just need to study how people do it in PeerDAS.
Well, on PeerDAS now they're both on top of Fulu, but beforehand they were just using an activation epoch. And I guess like the issue with Lighthouse is once we upgrade to like a new fork, all like the topics change and a bunch of other stuff happens. And without that a couple thousand lines of boilerplate that I was mentioning, we have to kind of like hack in this new fork version that we're talking about. And adding like a fake EIP 7805 fork into the code base. It can happen. It's just, yeah, I don't know. From our end, it's just a headache, I guess.
Okay, so
Yeah, you got
so
it.
it's hard for me to get like a consensus here. Like it feels like people are still a bit split, but tending towards an activation epoch instead. Yeah, I'm
Yeah, I mean, if you guys are already interoping, I don't want to like ruin the momentum or whatever. I just wanted to mention it, and I think in the future it'd be nice to always try to consider an activation epoch first because it's just a lot simpler. And like I said, for PeerDAS, they were able to interop and create proof of concepts pretty quickly with that like paradigm. But we don't want to do that here. That's fine.
Yeah, I think from Loadster side, we can model it internally as a fork as we do right now, and just not add or update the fork version. And then I think it should interop still. I guess that's the only change we would need to do.
okay. All right, so trending towards unique fork version pending like more difficulties, I guess.
But yeah, it
Like,
would be good to hear someone from Nimbus, I guess.
okay, I can reach out. I mean, I don't know anyone from there, but like I can actually try if you guys, I don't know, did someone say they actually reached out already?
Someone from Nimbus reached out to me like I don't know, like a month ago. So I can ask him again.
Okay, perfect. Okay, that sounds great. Cool. Um, yeah, we don't have that much time left, but I guess does anyone have other like issues or blockers or things they want to define for you guys? What's okay, maybe one question I have is like what's the progress on the next interrupt? Like is Lighthouse having difficulties or is it just like progressing nicely and
Yeah, on the Lighthouse side, we just need to implement the like unique fork version, and then we'll be able to start trying to interop. So that's what I'm working on right now.
awesome. Okay, great. That sounds great. Any other updates for other clients or
Yeah, I can give an update from Teku.
great.
Actually, I started interoping with Lodestar and Prism. Yeah, it works pretty well. I'm just having an issue with Dora for some reason, which is crashing. And yeah, from in Teku, actually, we have also some boilerplate code to add when we have a feature fork, but that's already done. And so yeah, I personally would prefer keeping it like that and not going back to the epoch transition. Like, so yeah, I'm not sure about that. That would mean that we need to do some to revert some code and do some changes. So yeah.
Okay, cool. Yeah, great. Thanks. I mean, yeah, that's awesome. Any other? I mean, yeah, even looking at the chat, I think Justin also mentioned he will be in favor of a unique fork version. So it sounds like we are probably gonna keep it that way. If Nimbus also like it will also work for them, but I haven't heard from them. I don't even know if they're working on FOCIL. Are they?
They aren't started, as far as I know. But I will ask again. Yeah.
Okay, great. Okay, sounds good. Perfect. Thanks. Okay. And yeah.
For Nethermind, just kind of improving the code and working on some review comments. I also swapped to doing this unique fork based on, so built on top of Pectra. So is that matching what other clients are doing, which are interoping at the moment? Or?
Yeah, so I opened a PR to Ethereum Genesis Generator to support EIP 7805 fork timestamp so that EL can use that to determine whether the EIP 7805 fork is activated. So when I tested it locally with get prototype, it works well, but the PR hasn't merged yet, but I will let people know once it's merged. So current interop is just like, it worked with the EIP 7805 fork in the CL. So we are using the EL that doesn't check any fork version. So it's just like a hacky version. I guess we wanted to just see if CL can interrupt. But in the future, when we have this Genesis generator, then of course we wanna make sure our EL is ready and make sure it uses EIP 7805 fork as well. So yeah.
Okay, sorry, I didn't quite understand. So what are you doing currently then? You don't have a custom fork?
So currently, when an engine API like fork choice v3 or new payload v5 is called, it doesn't check any fork version, like whether it is in Osaka or in EIP 7805 or in Prague or whatnot. So it just lets CL call whatever they want. But in the right way, it should check if current fork is EIP 7805. So I just updated get prototype to reflect this change. So you might want to check the PR. But if you do that now, then it will break because currently kurtosis doesn't set EIP 7805 timestamp. But I guess it will be merged in soon. So yeah, maybe you want to wait like 1 or 2 days, or if you really want, I can make I can upload the Ethereum Genesis generator Docker image so that you can use it for your local testing.
Okay, thank you. I think I understand. Maybe we can discuss more async.
Sure, good.
Awesome. Yeah, let's do it and actually discuss it more async. Thanks everyone for coming and sharing progress and for the presentations. I thought it was nice. And yeah, let's see you all online. Bye bye.
Thank you. Bye.
Cheers, bye.